So our research project was on walking and systolic blood pressure. In our group is me, Maria, Patrick, Laney, and Sofia. So first off, we're gonna go through the background, then the description of our data, then our statistical methodology, and finally our conclusion. So the background information. The issue we investigated was whether there is a statistically significant difference between measuring a change in systolic blood pressure with a digital or a manual cuff. We also had other variables in our data, but that was our main research question. And our plan was to identify and create a research question, then identify the variables in our data. And after that, we defined both our null and our alternative hypotheses. We analyzed the data we were given and plugged the data into SAS. We selected the correct t-test. We decided to do a 2 independent sample t-test to analyze the data. And then we observed and analyzed our SAS output in order to draw our conclusions from the output using our p-value and the test statistic. Also using the histograms and the QQ plots from SAS to further analyze our data.
Okay, so part 2 of our project is the description of our data. For our variables, our data consisted of 2 independent variables, which were the digital versus manual cuff that measures blood pressure. Our dependent variable was the difference in measurement pre and post walk based on the cuff used. Our other measured variables were the environment that the participants walked in and the speed that the participants walked at. And lastly, for our creative variable, we calculated the difference between pre-walk blood pressure and post-walk blood pressure. Okay, so for the description of our graphs, the histogram for people using the digital cuff is left skewed, as the data is generally spread out more on the left side, with fewer extreme values on the right side. Further, the histogram for people using the manual cuff is bell-shaped or symmetrical with relatively even data. And our QQ plot demonstrates that our data is not normally distributed.
Okay, so now we're going to go over our statistical methodology. So we decided, we looked at our data and we saw that there was 2 distinctive groups, one being the manual cuff and one being the digital cuff. So we chose to conduct a 2 independent sample t-test in SAS because we saw we had 2 distinctive groups, but we also decided to include a new variable in our test because we were testing the change in systolic blood pressure. And lastly, we observed the test statistic and the p-value in order to make a conclusion about our data. So this is the setup of our conducted tests. So for our hypothesis statement, we put 0 because our null hypothesis states that there is no difference between the groups. And we put 2 in for our sides because it's a 2-sided t-test. We were looking at our newly created variable diff, which is the pre-measurement minus the post-measurement. And for our categorical variable, we put in the measurement method.
So for the conclusion, we decided we did not reject the null hypothesis because the p-value from our SAS output was 0.3688. Therefore, we accept that there is no difference between the change in systolic blood pressure after a 30-minute brisk walk when measuring with a manual cuff versus a digital cuff. Some of our ramifications, same efficiency in technological development. We found that both the manual cuff and the digital cuff have the same efficiency, so there's no difference when it comes to using one or the other. And this research could lead to further developments in technology that would be more efficient at measuring systolic blood pressure. And then 2 limitations, the sample size and the time limitation. If we had chosen a bigger sample, it would allow for more generalizability. And the time limitation, 30 minutes may not be enough time to differentiate the two groups between the manual cuff and the digital cuff. And then 4 things we would change, this, again, the sample size, different types of exercise, so measuring the distance in systolic blood pressure after different activities, not just a 30-minute walk. A longer time period, instead of 30 minutes, we may increase the time to possibly an hour to get a better chance at the possibilities of differences in the cuff. And lifestyle changes, so that could affect the outcome too. Changes involve making modifications to the individuals in the study's diet, exercise habits, or other behaviors. Thanks for watching.
How long is it? I feel like it's very short.
You-
Oh no, that's in our video.
What?
Isn't it? That's all. We can cut it out.
We can cut it up.
Oh, yeah, we can cut it. I was like, wait, what?